Hello and welcome back to One Day to Get 5 MA for AP Precalculus. This is episode 12, and today I'm going to be doing a problem from Unit 2, which I created. So let's just get into it. So the problem is asking us to graph the function f of x equals 5 plus 2 log base 2 of negative x plus 1 and its parent function. And then it wants you to state the transformations that will produce the graph of f from the parent function. So before I do the problem, give it a go yourself, and then check back and see how you did. Okay, so assuming that you have tried to graph the function and say its transformations, I'm going to First, I'm going to graph the parent function instead of graphing the f of x first, because when we have the parent function, it makes it a lot easier to use the transformations and then just see the graph that'll be produced. It makes it a lot easier to produce the graph, I should say. So let's think about some input values that we could have that would create nice output values for log base 2 of x, which is our parent function. If we have log base 2 of 1, right, that will be equal to 0. So we can have this point here. Log base 2 of 2, of course, will be 1. And pretty much any other integer, any other whole number multiples of 2 will work. So 4, we'll have 4, 2. 8, we'll have the point 83. And also, we can have some points from 0 to 1. So if we have the point 1/2 negative 1, that is valid because log base 2 of 1/2 is equal to negative 1. And the point 1/4 negative 2, and the point 1/8 negative 3, if you notice the pattern. So we kind of have this shape here, where it has this asymptote line at x equals 0, right? Okay, and it comes up, and then it's getting its rate of change is slowly decreasing, so it is concave down, as you can see. Alright, so this is the parent function, y equals log base 2 of x. Okay, now what I'm going to do is I'm going to switch my highlighter color to a different color. Or actually, first, let's look at the inside of this function. If you notice, we have negative x plus 1. What we want is to change this to some factor that is multiplying the whole inside, because from that we can get the horizontal dilation / reflection, but we need to be multiplying the whole inside. So if we take this negative out, we get negative x, minus 1. Right, and the x has nothing multiplying it, so it's basically we have our translation, and we have our dilation / reflection, and we want that dilation, that factor, to be multiplying the entire inside, not just the x. Okay, so the order that you want to list the transformations in is generally you want the horizontal dilation and / or reflection to be first. Okay, so for us, that's going to be reflection over the y-axis, which will be horizontal reflection, right? And then, by the way, I get that from that negative. Should have pointed out. And then if you notice, we have this minus 1 here. Generally, you're going to have your, if you do have one, you're going to have your horizontal translation second. So that's translation 1 unit right. Okay. Switch to another color. Let's do green. Then you want to list your vertical dilation and slash or reflection. So vertical dilation and slash or reflection. And for us, that is a vertical dilation by a factor of 2. Okay. And there's one more thing we have to worry about. Let's switch to yellow. This plus 5 over here is what we're going to do last. So, generally you want to do the vertical translation last. So we have a translation 5 units up. Okay, so those are all of our transformations from log base 2 of x. Now, what I'm going to do is transformations of our parent function. Now what I'm going to do is I'm going to transform all of the points one at a time until we finally reach that final f of x, right? Until we finally reach the function that we're trying to graph, and then we can graph it. Okay, so first let's reflect it over the y-axis. So this point here, oops. Okay, so this point here at 1, 0 is going to go to negative 1, 0. This point at 2, 1 is going to go to negative 2, 1, and so on and so forth. So it's going to look something like that. And all these points too. Okay. Then we want to translate it horizontally. So that is going to be right. Okay. 1 unit right. So this point is going to go there. That point is going to go there. Point's going to go there. And point's going to go there. Okay. Then we have a vertical dilation by a factor of 2. I should have said a stretch, because that would be more specific. Okay. Keep accidentally doing that. I need to figure out how to stop that. Okay, so this point at negative 7, 3 is going to become 2 times as high. And so is this one and that one. And that point's going to stay the same. And then this point here is going to get farther away from the x-axis, but it's going to be going down because it's already negative. So it's going to start to look like that. Just a little more steep. Okay, then a vertical translation. Okay, so this is our final one. 5 units up. Okay, so this point here at that has a y value of 6 is going to go to a y value of 11. This 4 is going to go to 9. 2 is going to go to 7. It's going to go to 5. that is going to go to 4. Or wait, I apologize. That should go to 3, because negative 2 plus 3. Or wait, I just realized I did some of those green points wrong. I apologize. Oop. It's a disaster. Okay, what I wanted to do is I wanted to have this green point here be, so notice that and negative 2 is going to get stretched down to negative 4. My apologies. Let me just put that blue point back. Okay. Alright, continuing on. Okay, that point at, looks like it's at negative 4. So that's going to go to 1. It's at negative 6. It's going to go to negative 1. Alright, so we're going to have something like that. And that will be our final function. So, if I try my best to sketch that. Alright, let me just draw that asymptote line, because it's going to be going down. We're going to have an asymptote line at x equals 1, because it just got shifted over right 1. Okay. Now let me label this. This is y equals, or no, f of x equals 5 plus 2 log base 2 negative x plus 1. Alright, so I can erase all these points now, but alright, never mind. That's gonna. Alright, so that is what the final graph will look like, and that is what the parent function will look like. And these are all of our transformations. Alright, this video is a little bit chaotic, I guess, because I need to figure out how to work my pen. But I hope that nonetheless you found it helpful, and I hope that you have a good rest of your day.